Hey guys, okay, so we are going to go over the More Stats practice assignment that I gave you guys for statistical methodology. I'm going to go through this really quick, so it's just going to be a quick tutorial video on how to handle each one of these problems that was in this, and hopefully this will help you guys get started on it and be able to finish it. Thank you again so much for your patience and learning these stats methods. I know it's going to take a little bit of time, but I tell you what, you're going to get so many rewards out of this later on. It is so good to have a statistical foundation. So let's get started. The first question is describing a potential relationship between death, anxiety, and religiosity. It's within the same group because we're not told that these are two different groups. We're just told the describes anxiety of death compared to tendency towards religious beliefs and practices. We can assume it's in one group because there is no specific group mentioned. So because it's within the same group and these are all quantitative variables, we're going to say that we're going to look for a correlation between the two. And so our stats method is going to be a correlation. We'll come up with our null hypothesis, which is going to be that there is no relationship between death, anxiety, and religiosity. And then our alternative hypothesis, which says that as death anxiety increases, religiosity might increase as well, or whatever you think is going to happen. It's really up to you as to what you want your alternative hypothesis to be. In order to calculate a correlation, we're going to go ahead and calculate Pearson's R, correlation coefficient. It is essentially just a statistic that is going to tell us whether or not these two variables, death, anxiety, and religiosity, are correlated and whether they're going to be positively or negatively correlated. For more information on correlation and what that means, there is a link on the actual assignment down here for correlation. If you click on it, it'll tell you what a positive and negative and no correlation means, and also describe what your different R values mean that you can get. Now, I'm not going to describe that right now yet because we've already been through that in previous videos and lessons, but I will kind of touch on it a little bit today, but make sure you read that page in order to better understand what's going on. So for the Pearson's R correlation coefficient, I'm going to say equals and then CORREL. This is the formula within Sheets that's going to allow me to calculate the correlation. Click on it. And now if I click on the help, it'll tell me that the first thing I need to do is highlight my Y data set, put a comma, and then highlight my X data set. So I'm going to go over here. This is my Y data set, comma, X data set, and I just clicked and dragged to select it. And then, boom, I get my Pearson's R correlation coefficient. Now we can also calculate the R square value if you want to, and the R square value is essentially just equals this number, shift 6 for the caret key, and then press 2 for your squared, and that gives you your R square. Your R square is essentially just a description of how, basically it's asking you, is the change in your X variables indicative of all of the change in your Y? Okay, so it's not asking whether it's positively or negatively correlated, it's just asking whether or not the physical change in your X values is at all related to the change in your Y values and how related it is. This scale goes from 0 to 1, with 0 being the X, okay, 0 meaning that the X is not indicative of change in Y, and the 1 meaning that it is. Okay, so hopefully that's an okay description for just for now. We did the R square values in a previous lesson, but you know, if you've forgotten, that's what it means. Okay, so here I can go ahead and say, see that my Pearson's R correlation coefficient is negative 0.7 if I round. So if I go into here, I can see that a positive 1 is a perfect positive correlation. Negative 1 is a perfect negative, and anything in between is going to be moderate, and then if I'm at 0 or close to 0, it's going to be no correlation at all and no relationship. So if I look at this, a negative 7 is going to fall right about here, so I'm past the midway point, so I can say that there's a moderate correlation between death anxiety and religiosity. Because it's negative, it means that as my death anxiety goes up, my religiosity actually goes down. So that's really interesting to me. Okay, so because I would have guessed the other way. But so that's what it means, right? We have a negative correlation. So in other words, in my conclusion, okay, I can go ahead and say that there is a moderate negative correlation between death anxiety and religiosity, meaning that as death anxiety increases, religiosity tends to decrease. And there we go. So that is our idea of what is happening here. That's how you would run a correlation. This number, really, we can include it, but it doesn't, all it really says is that, again, we're kind of moderately correlated because it's right between 0 and 1, so the change in x is somewhat indicative of the change in y. Now we go down to example 2. We have a different data set. This describes two groups, older and younger adults. That's a qualitative variable, versus countable variables down here. These are going to be the quantitative variables. So we have qualitative and quantitative. This is going to be a t-test. Now we've seen that when we try to calculate the t-test using the Google Sheets, it comes up with a different number. I'm looking into why that is, because they're probably using a different t-test equation. There are many t-test equations. The one that we need to be using for IB, though, is the one we should probably use. So if you click here on the IB t-test, scroll down, it'll show you this is what we call the student's t-test. So the reason why the Google Sheets is probably different, and I'll look into this a little bit more, it's probably because it's not using the student's t-test. But this is what IB wants you to use. So in other words, this formula is describing, you're going to take your mean from your sample 1, you're going to subtract the mean from the sample 2 from it, and that's going to be over the square root of your standard deviation of your data squared over the number of data points in sample 1 plus the standard deviation for your sample 2 squared over the number of data points for sample 2. Okay, so we're going to go ahead and kind of break this down in the sheets in order to do this equation. The first thing we need is the mean of both groups. Okay, so to find the mean, you come in here and you say, I'm going to go ahead and say x1 mean. Okay, and then over here I'm going to say x2 mean. Remember that x1 and 2, they're not talking about the X-Men movies, although that would be awesome. It's just talking about the mean for your sample 1. So x1 equals sample 1, that's our older adults. x2, sample 2, younger adults. So now to find the mean, we say equals, and then we hit average. We just type that in, and it should come up on the list. Click on it. And it's going to tell you that we need to go ahead and average just a range of numbers. So I'm going to go ahead and grab and drag, and then close the parentheses, and there's my mean for all these numbers. Now I'll go over here to the x2 mean, and I do the same thing. Equals, average, grab these numbers, and bam, this is my sample mean for 2. So I got my two different sample means. Now I'm getting my standard deviation. So I'm going to say my SD for, I'm going to say x1 SD, and then x2 SD for my standard deviation. Now to find the standard deviation, you're going to say equals, and you want to say STDEV. Okay, it should come up here, STDEV, and you're going to go ahead and choose your data set. And then over here, for my x2 SD, I'm going to do the same thing, STDEV. Right? And I got that. Okay, so now I know that according to this equation, I need to actually take those standard deviations and square them. So I'm going to go ahead and do that really quick. I'm going to say equals this number. Okay, shift 6 for my little caret key, a 2 for my exponent, and there is my number. And I can just drag this box over to go ahead and have it calculate it for this guy as well. So we're good to go. We have our standard deviation squared, and we have our means. So now we're ready to go ahead and do this this thing. Also, for our n is the number of data points that we have, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data points per thing. So I'm going to say n equals 10 for both samples. Okay, because that's the total number of data points that we have. So now we can go ahead and pull out our handy dandy calculator and go ahead and start doing some good old calculations. So we see in the numerator, it's x1 minus x2. Okay, so I'm going to go ahead and say, so that's going to be my x1 mean minus x2. So it's going to be 44.5 minus 28.1. 16.4. Okay, I'm going to go ahead and start keeping track of this over here. So 16.4 is going to be my numerator. That's going to be over the square root of, let me see over here, square root of, okay, so I got 75.4 basically, okay, is my squared value. So 75.4. All right. My handwriting, over 10 because it's over n. Alright, and then we're going to add that to my other value, which is 73, okay, ish, 73 over 10. Okay, and now I'm going to go ahead and do some more calculations here. So that's going to equal 16.4 over, and let's go ahead and see what these are. So 75 point, oh, well actually I can do this in my head. So 75.4 divided by 10 is 7.54. 73 divided by 10 is 7.3. So I'm just going to have 7.54 plus 7.3, something like that. 14.84. Okay. And then I'm going to go ahead and do this. So 16.4 divided by 14.84 is going to be 1.105. So 1. Oh, and actually, whoa, now wait a second. I needed to take the square root of that, didn't I? Oh, this is my classic Mr. Garner mistake with the calculator. There we go, and that gives me, sorry, 3.85. 3.85. Yeah, my math teachers were always really dubious in my ability to do math. Can you tell why? All right, so 3.84, there we go. All right, so we have our t-test value right there, and we are good to go. So our t-test value, which I'll put right here, is 3. I've already forgotten, 85. Okay. All right, so we are good to go now with our t-test value. We got that. We have, oh, we need our standard deviation. So our degree of freedom. So we need our degree of freedom. Our degree of freedom is going to equal n minus 1. Okay, and now there's a difference between the capital N and the lowercase n. The capital N is your overall, like all your samples put together, their size. A little n is just one sample. So big N is going to be 2 times 10, which is 20, minus, whoops, minus 2. Okay, and minus 2. So in this case, it's going to be 20 minus 2, which is going to be 18 for our degree of freedom. So once again, how did I get that? Big N is all of your data points. So I have 10 in each sample. I add all that together. It gives me 20, right? And then I minus 2, and that gives me my degree of freedom of 18. So I got a t-test value of 3.85, degree of freedom of 18. I need to be on the t-test page that's linked here to the assignment. Scroll down to my critical values table, find 18, go over, what was it, 3.85, 3. How do I keep forgetting? 3.85, okay. Okay, so we are actually, in our t-test, we are right between these two right here, which is my 0.01 and 0.001 degrees, confidence interval. So in this case, I am more than 99% confident. Remember, these numbers were all I really needed. This is my 0.05. So I'm more than 99% confident that that is a significant result. So here in this case, I can say that there is a significant difference between life satisfaction in older adults versus younger adults, those youths, right? And so your null hypothesis would have been that there was no difference, your alternative was that there was, and you would have said something, so this supports your alternative hypothesis. Okay, now going on to our chi-square. Now our chi-square is going to be comparing two qualitative variables. So we know it's chi-square because we can see it's female versus male, which is a quality about someone, not a quantity. And we have the highest level of education earned, which is in terms of its name. So high school, bachelor's, master's, PhD. This again is a qualitative thing. How high their education is a quality about someone, not a quantity. So we're going to go ahead and calculate this using this contingency table. It's basically already set up for us. So all we need to do is go ahead and fill it out. Now remember, your contingency table data values are one thing. That's fine. That's what you start with. But you need to also calculate your row totals and your column totals. So we're going to go ahead and do that right now. So my row total over here is going to be adding all these numbers together. So how do I do that? I say equals, and I'm going to say this guy by clicking on him, plus this, oh, excuse me, this girl. I'm on the female row, excuse me. All right, plus, and bam. Okay, so that's going to give me my row total. So I basically just added all these guys up. And then I'm going to go ahead and grab this little square, bring it down, and boom, it'll go ahead, automatically calculates it for the next row. Over here for my column totals, I'm going to say equals, click, plus, click, equals. And then I can just go ahead and drag that over here as well. Boom, I'm good to go. So now I have my row totals and my column totals. Why did I need those? Because remember, you need those for your expected value when you're working with a contingency table. So the first thing I'm going to do here is I'm going to set this up and say that these are my observed values. Now, what are my observed values? So that is all the values that they gave me to start with. These are the values I collected when I went out and did my research and collected my data. Okay, so what do I do with these observed values and how do I put them down here? Well, first off, I need categories to say my observed values. Each value has a meaning. For instance, this 60 represents the number of females that went to high school as their highest form of education. This 44 represents the total number of males that got their bachelor's in education as their highest education. So each number means something, right? So I'm going to go ahead and write down all those categories, and I need to start here with high school. So I'm going to say high school if you were a female, okay? High school if you were male, and then I'm going to say my bachelor's if you were female, bachelor's if you were male. Okay, master's if you're female, master's if you were a male, PhD if you were a female, PhD if you were a male. These are what are called categories in a chi-square. And basically, each number is going to represent a different category in your observed values. It's a good way to keep track of things. So these are our categories. Now, what are our observed values for them? So high school female is 60. I'm going to type 60 in there. High school male, 40. Bachelor's female, 54. Bachelor's male, 44. Master's degree female, 46. Master's with the male is 53. PhD with the female is 41. And PhD with the male is 57. All right. Now we need our expected values, and this is where it gets really fun. So the expected values are going to be calculated using the formula row times column divided by grand, just like we did in our DBQ exercise. I'm going to put that here. So expected equals row total multiplied by our column total divided by our grand total. Okay, remember this is your grand total down here. I would like to make this box a slightly different color to offset the grand total. All right. So now I'm going to go ahead and start doing my equation. So row times column divided by grand. So let's go to high school females. Okay, my row total is here. Column total is here. And my grand total is here. How would I do that? I would say equals. I'm going to go over to my high school females row total multiplied by my column total divided by my grand total. Now, I need to put this in parentheses here because otherwise it's going to mess up. So divided by my grand total. Got it. I'm going to show you that again. Let's do it with the high school males. So high school males, all right, over here, equals, make sure my parentheses is there. Okay, row total multiplied by column total, close parentheses, divided by grand total. All right, let's do it again for the bachelor's female. Okay, bachelor's female, row, oops, forgot my parenthesis, row, multiplied by my column, divided by my grand. Next one, bachelor's male, parenthesis, bachelor's male. Okay, starting here, row, okay. Column, close, grand, equals. Okay, master's female, row, times, column, divided by grand. Okay. Now we have our masters with male, row, times, column, divided by grand. The most common mistake here when you're doing this is to accidentally choose the wrong column or row total. Got to make sure you're starting in the actual cell that represents the number you're looking at, or the category. So PhD females, got to start here, row, multiplied by, go back to the PhD females, column, close parentheses, divided by the grand. Grand never changes, so that's kind of an easy one to figure out. Male, PhD, boom, row, column, divided by the grand. All right, now that you have your expected values, the hard work is done, and you can start doing your typical chi-square setup. So you'd say O minus E squared, O minus E squared divided by E, and then the sum of O minus E squared divided by, E. Okay, and you just do your calculation. So for O minus E, you say equals your O minus your E. Boom, you only have to do it for one. Grab that little box in the corner, drag it down, and it calculates it for all of them. Oh, it's so nice. Then you go over here, equals this number, caret key, shift 6, press 2. Got it? Only had to calculate for one. Drag that box down, boom. Over here, O minus E squared divided by E, okay, equals, here's my O minus E squared, divided by my E. Drag it down, easy. Okay, then the sum equals SUM, which is my sum, and I just want to drag down across this whole column. There's my chi-square value. Now your chi-square degree of freedom is going to be a little bit different than your other degrees of freedom. It's going to be n minus 1, where n is going to represent the number of categories you have. How many categories do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so my degree of freedom is 8. Okay, now I can't use the t-test critical value chart for my chi-square critical values, so I exit out of that, and I find the one that says chi-square under the assignment. Scroll down, find it. Okay, and now I know that my degree of freedom, so actually I had 1, 2, 3, 4, 5, 6, 7, 8 categories. Sorry, my degree of freedom should be 8 minus 1 equals 7, right? Because my degree of freedom equals n minus 1 in terms of chi-square. So sorry about that. Thanks for catching it if you already did. Degree of freedom is 7. My chi-square is 8. Come in here. Degree of freedom 7. Chi-square is 8, so it's somewhere between these two. Oof. I'm only 50% significant, or between 50 and 75% significant. That is not good enough. We need at least this one over here, and less than 0.05, which is a 95% significance. So we cannot reject the null here because we do not have a significant statistical difference between males and females that go to different levels of education. So we say we reject, fail to reject the null. There is no significant difference between males and females in terms of highest awarded education. Okay? Alright, and that would be, obviously your null hypothesis would be there's no difference. Alternative could have been anything you wanted. You could have said that you thought that males had a higher degree of education. You thought that females had a higher degree of education. Could have said anything you wanted. But we're going to fail to reject the null, so it doesn't matter, there's no difference. Example 4. We're again looking at two different countable variables within the same group. We are not told that these are different groups, so therefore it is a correlation. Okay, so we're going to go ahead and do our good old Pearson's R correlation coefficient. So equals CORREL, just like we did before. Grab all my data, make sure I grab it all. Might have to scroll down while you're clicking and dragging. Okay. Gives me that. Oof. All right, 0.5. It's pretty lukewarm. Now let's go ahead and do the R square just for kicks. Equals this number squared. Oof. All right, so in this case, we can see there is a weak to moderate correlation between achievement on a standardized test and GPA. It is not strong at all because our Pearson's R is 0.5, and if you're struggling to remember what that means, you go back over here to the correlation. Pearson's R 0.5 is right about here, so it's somewhere between being not significant and being significant in terms of its positive correlation. So it is a weak to moderate positive correlation, and our R-squared value is saying that the change in X is really not very indicative of our change in Y in terms of our numbers. So yeah, not very strong. Now finally, for example 5, we're going to do chi-square, but this one's going to be a different kind of chi-square because we can see it's asking us about random distribution. There's two basic types of chi-square, and you can actually see this if you go into here to the chi-square information that I gave you. There's the test for independence, which is saying is the presence or absence of two different things significantly related. That's kind of what we just did with the males and females in the college. There's another one, another type that is also here, which is the goodness of fit, chi-square goodness of fit. The chi-square goodness of fit is like, do things, are things related in terms of their randomness? Are things in nature happening randomly, or is there like some sort of just change from the mean? This is basically the same question that we were asking with our M&M question, if you remember the last chi-square example we did with the M&Ms. Okay, so this one's going to be a lot easier in terms of how to set it up. So in this one, we are asked, there's a card machine that's dealing 1,600 cards, supposed to be completely randomly. This is how many cards that the machine deals us out of each one of our different hands. Okay, so we can see spades, hearts, diamonds, and clubs, and these are the number of cards that they gave us for each one. So we want to see, is the machine actually dealing out stuff randomly, or is this distribution very different from that, and we should kind of suspect that the machine is not completely random. So how do we figure that out? Well, okay, so these are our observed values, excuse me. What are our expected values? Well, our expected values is what we would expect if the null hypothesis is true, which is that, yeah, it is completely random. Okay, so if it was completely random and the card machine deals us 1,600 cards and there are 4 possible suits, then we would expect it to be 1,600 divided by 4. We should get 400 cards of each suit if completely random. Okay, so if that's true, if it's completely random, we should get 400 cards from each suit. We can literally just put 400 up here and just drag it down. And there's our expected value for each one. We should expect 400 of each one of these suits, okay, if the machine is really random. Now we go ahead and do our normal calculations. So we say O minus E, O minus E squared, O minus E squared, whoops, divided by E, and the sum of O minus E squared divided by E. I'm not going to do it for you guys because I already did that one up here, and you should be able to do those calculations at this point, and it should be pretty easy to do at this point, hopefully. If you do get stuck, please let me know. And then you can go ahead and tell me, what was your conclusion, right? Was it, what did you reject it, whatever, and make sure that you use the chi-square critical values chart. Please, please, please do not use the t-test or the correlation critical values chart because it's just not going to work. Guys, I hope you have enjoyed this video. I hope it's useful to you. I know it's very long. Thank you so much for your patience and your time in taking the time to be able to learn these statistical methods. I really, really appreciate it. Thank you guys very much, and I look very much forward to seeing you guys next Tuesday. Take care.